Good afternoon, good evening, and good morning, everyone. Thanks for joining us on this awesome day, which is the sysinternals 25th anniversary. We've had a lot of good sessions today. This session, we're going to do something just a little different. It's still around sysinternals, but it's going to be around sysinternals for Linux. My name is Mario Hewart. I'm a principal customer engineer. I joined Microsoft back in 1998. I've been in a few different roles in Microsoft through that time. All of it has been in software engineering, but sort of the thread and the theme and what I'm passionate about is software reliability and robustness. And as part of that, I've gotten to use the sysinternals tools for a long time, the various debuggers and things like that, to be able to get a glance at the internals of the system. As part of that passion, I wrote a couple of books. One is Advanced Windows Debugging, which covers the Win32 API layer, and then I followed that up with the .NET Advanced .NET Debugging, which is deals with the .NET and the CLR. And I've also got a couple of debugging diagnostics Pluralsight courses out there. And with me today, we've got Mr. Kevin Sheldrake. If we're really nice to him today, he might actually divulge a secret announcement, possibly. So, Kevin, do you want to give a quick intro and take it from there?
Yeah, so hi, I'm Kevin Sheldrake. I work for sysinternals in Microsoft. I'm a senior security software engineer. Before I came to Microsoft, I had a long history in Linux security, from penetration testing to reverse engineering, both at some conferences, got published here and there. And right now I'm working on Sysmon for Linux, which we are going to launch today. So sysinternals have obviously already released a couple of tools on Linux, Procmon and Procdump. And Microsoft has got a solid investment in open source software for Linux as well as for Windows. So this launch of Sysmon is quite a step forward. Sysmon is obviously a much more complicated and wider used tool. It's used across Windows on millions and millions of platforms, and bringing it to Linux is something that we're quite excited about. Yeah, so the Linux version of Sysmon, known as Sysmon for Linux, is a direct port from the Windows version. It actually shares the same code for the configuration loading and the filter engine. If you're already a user of the Windows version of Sysmon and you're used to making configuration files to configure that, then you can use exactly the same skills on the Linux version, build the configuration files in exactly the same way, and you can expect the event filtering engine to work in the same way as it does on Windows. So obviously the Windows version has a kernel driver which collects the information from which Sysmon makes events, and we needed to rewrite that for Linux. We used eBPF for that, which is a technology that allows you to write safe code that runs inside a virtual machine inside the Linux kernel. So it's kind of like writing a kernel module, but it's entirely safe. You can only read and write certain pieces of memory, and you can only run a very limited set of functions. But with that technology, you can collect a lot of information that is interesting about the system and send that to the userland version of Sysmon in order to make events. In order to simplify that process, I first wrote a library called sysinternals eBPF, which we're also launching today. This is a shared library that's linked with your userland code that lets you load and control your eBPF programs. And it also comes with an eBPF code library featuring snippets which you can use as inline functions to access the facilities that the shared library offers. Now, the benefit of using this is that we can support any kernel version from version 4.15 onwards, and we don't require you to recompile the kernel with any special options or to install any symbols packages. We currently support a range of events directly ported from the Windows version. So things like process creation and termination, file creation and deletion, network events, raw access read and access process. And we output in the same XML format that the Windows version outputs, but instead of going to the Windows event log, we obviously output to syslog. If you've got a theme that can understand Sysmon messaging, which it collects from the Windows event log, and you can reconfigure that to collect information from Linux syslog, then it should be able to understand the events that we're outputting because they're in exactly the same format. The code will be available today on GitHub at the URLs seen on the slide, and there are also deb and RPM packages available. Follow the instructions on the GitHub to find out how to access them. Let me show you what that means. If I tail the syslog in this window, we can see we've got our normal system messages that come out. And in here, I'm going to start up Sysmon. with a configuration that is going to highlight all of those events. We can see it loading in the right-hand window in the syslog, and now we can see it's already generating events. If I was to run an ls, then we can see in here, this is the XML of the sysmon is outputting, and you can see things like the command line here, the current directory, there'll be usernames, parent processes, etc. But of course, that XML is a bit difficult to read. So what we're going to do is just quickly pipe that through another tool that comes with. And as you see, that just turns it into human readable form. It's just taking the XML and reprocessing it so we can see stuff. So just to give a quick demo of the sort of things that it can do, if we were to go and wget a file, which is the sort of thing like a malware, like a ransomware or a coin mine or something might do, might go off and fetch a file. Then in the right-hand side here, we can see the program that made the network connection, the user, the IP, and the port. Obviously, that's also created a file, so we can see the file that was dropped here, which is index.html, by that process. And one last thing I'll say, I've got here a symbolic link. If I was to just to access the hard disk directory, you can see here we've got a raw access read event occurred against the actual device, regardless of the name that I actually accessing it with. Yeah, so Sysmon for Linux is launched today. It's available on GitHub and in deb and RPM packages, as I mentioned. So now I'm going to throw back to Mario, who's going to talk about Procmon.
Awesome. Thanks, Kevin. Super excited to see Sysmon, yet another, sysinternals tool coming for Linux, and especially being as useful and as widely used as it is. Also kind of excited about the sysinternals eBPF library, but we'll talk a little bit more about that later on in the roadmap as it relates to Procmon. So Procmon, as you know, it's a lightweight system activity tracing tool. We have brought it to Linux, and it's been around probably about a year and a half at this point. Much like Sysmon, it is based on eBPF. We do it slightly differently today than what Sysmon does, but we will be moving over shortly to the library that Kevin was mentioning, which is the sysinternals eBPF library shipping today. Now, Procmon, basically what it does, it traces all the syscalls for all the processes running on the system. And it gives you things like how long did the syscall take to run, what was the result of it, it gives you the inbound arguments, and it can actually even give you call stacks with a little bit of an asterisk there. You have to make sure that symbolic information is available and frame pointers are actually included in order to be able to get proper clean call stacks. As you can imagine, tracing all syscalls for all processes on the system is going to generate quite a bit of data. And so what we've done to simplify that a little bit is we've built a UI around it. It's a TUI, actually, a text user interface. And it allows you to do things like filtering or searching if you want to hone in on specific processes that you're interested in. Just like Sysmon and all of the sysinternals for Linux tools to date, they are all open source, and Procmon lives at this URL. Now, instead of just talking about it, let me jump in and give you a demo, quick kind of lap around to see what Procmon looks like. So I'm in the terminal here, and in order to get Procmon to begin with, you have to install it. So on Ubuntu, it would be something like this. Now I already got it installed, so I'm not going to run this, but it's pretty trivial to get it. In order to run it, you do need to be sudo, and all you got to do is sudo procmon and type in the password. So up comes the TUI. And you can see here that it's got each of these events that are logged here is a syscall that a process is making. And we've got the different columns here, like timestamp, the process ID, what the process was, the syscall itself, the result code, duration, and then some details around it. You can see that it just continuously keeps collecting events. I'm going to pause that for just a second. You can use F5 for that. And if you wanted to get a little bit more information on any of these given processes, you can just select the one that you want. You hit enter, and you'll notice that we have an additional piece of data here with the stack trace. In this particular case, the stack trace is not clean, likely as a result of frame pointers being omitted, and so you won't get clean call stacks in that case. Couple of other quick things. Let's say that, you can see here that I've got process G main, I got SSHD, systemd. There's a whole bunch of processes. If I'm interested in a particular one, I can just hit F4 to filter. And let's say I'm interested in SSHD, right? And so now you're actually filtering and you're getting just the SSHD process itself. Another kind of cool thing that we have is stats F8. That gives you a breakdown of the top 10 syscalls in terms of counts and total duration. So if you ever feel that you're in a situation where a syscall is being hit too often or is taking too long, this is a great way of just finding what that is. Last thing I just want to quickly talk about is the export. So F6, all that does is just dumps all this data into the data store, and you can use, currently it's stored in SQLite, and you can use the SQLite CLI to do your own queries and manipulate the data in any way that you want. So that's kind of a quick lap around for Procmon. Now I'm going to switch back and talk about yet another tool that we have, which is also widely popular on the Windows side of things, and it's called procdump. And at the end of the day, what procdump does, it creates a static snapshot of any given running process, right? And the snapshot is nothing more than the state of the entire application being dumped to a file so that you can take that file, move it off of a production machine, and debug it post-mortem to get at the root cause that you're trying to find. We have ability to get these static snapshots on Linux. They're called core dumps. On Windows, it's crash dumps. So we have that capability today in Linux. You can use your favorite debugger, right? You can use GDB, you can use LLDB, and they've got commands to generate these. There's also one wrapper around GDB that just makes it slightly more approachable. It's called gcore. So with that, if we already have these tools, what's procdump all about, right? And the power from procdump really stems from its monitoring and triggering capabilities. Oftentimes, when you're running into issues in production, you don't know when the issue is going to happen. You might have some signals in terms of, when the issue happens, we're running high on CPU, for example, but it's completely unknown in as far as when or how it happens, right? And so procdump, what that allows you to do is say, monitor this process. And when a certain event or activity happens, that's when I want you to automatically generate a core dump. And those are called triggers. Today, procdump has triggers around CPU, meaning you can specify thresholds for, upper and lower threshold for CPU. So for example, my process is consuming more than 90% CPU. I want you to create a core dump. Similar thresholds exist for memory. We also have a thread count trigger, meaning that if for whatever reason threads start spinning out of control, you can say that once the thread count goes above X, I want you to generate a core dump. Similar with file descriptor counts. And one other trigger that we have that was actually added very recently, super exciting, is triggering core dumps based on specific signals. So if your application ends up getting signals that are unanticipated, or there's some issue in the signaling logic, you can now say, procdump, monitor this process, and when a particular signal comes through, generate a core dump. Another interesting integration that we have with procdump is in regards to .NET Core 3.x and higher. As a runtime, .NET Core will allocate quite a bit of memory, going on the assumption that, of course, your application is going to use it. And so when you use the normal mechanism, quote unquote, to generate core dumps, those core dumps end up getting really, really, really big. And that presents somewhat of a challenge in terms of the logistics of managing the core dump. So you've got, let's say a 5 gig core dump on the production machine that you now got to offload onto somewhere else and then use the debugger, right? It turns out that .NET Core has its own dump mechanism. It's not a different core dump file format at all. It's just that it's very selective of what it puts in there. And it only puts things in that it knows is being used. And you can tell .NET Core to trigger a core dump. And that's precisely what procdump will do in these cases. So instead of generating its own core dump, it simply tells the runtime itself to go and generate it for you, which results in smaller and more manageable core dumps. Just want to make it very, very clear here, though. Procdump doesn't care if it's .NET Core or any other running process on Linux, right? It will generate core dumps for it. So this is not something that's specific to .NET Core or anything like that. Any given process on Linux, procdump can generate core dumps from. Much like the other tools, it's all open source, and here is the link on GitHub for where procdump for Linux lives. So with that, let me jump into a quick demo and show you what that looks like. All right, so the first thing we got to do is make sure we get procdump onto the machine. So we can do something similar to this on Ubuntu. I already have it installed, so I'm not going to bore you with that. Much like procmon, procdump does require sudo. So if we just do sudo procdump, it gives you the banner and it tells you the different triggers that are available and the switches for it. So for example, the -C, upper and lower, is for CPU triggers, M is for memory, thread counts, file descriptor, etc. So the one thing really that's required when you run procdump, you don't even have to have a trigger, in which case it becomes an on-demand core dump. But you do always have to specify which process you want the dump being taken off of. And that's when you use the -P switch followed by the process ID. And there's a plethora of ways of getting the process ID. So I'm going to switch over to this window. I'm just going to run some arbitrary thing in the background. So we use htop. And let's say I wanted to generate a core dump off of htop. So in this case, I'm using ps-a to find my htop instance. This is the process ID. And now I can do sudo procdump -p. And procdump runs. We don't have any trigger specified. It's just an on-demand core dump generation. And we notice that right away a core dump of htop is generated. For the same htop instance, I wanted to say, you know what, when threads go over 5, I want you to generate the core dump. So I use the -T switch followed by 5. Now it's just sitting here and it's not actually producing a core dump. Primarily because likely htop isn't using 5 threads. It would be highly unlikely for an application like htop to use 5 threads, right? So I break out of this and just say, you know what, as long as it's using 1 thread, generate a core dump. And we see right away that procdump detected through that trigger that there was 1 thread and a core dump was generated. Now these core dumps, like I said before, there's nothing special about them. They're just regular old Linux core dumps. So you can load them up in GDB, LLDB, or whatever other core dump analysis program that you might have. So that's kind of the brief introduction to procdump. Super, super powerful tool, especially in production when you don't know when certain issues are happening. And so for the roadmap, we've got these 3 tools out there. I'm going to let Kevin talk about what's on the horizon for Sysmon. Kevin, take it away.
So version 1 will be released today, and we have a set of events. The first thing we're going to add are some Linux-specific events, such as monitoring the BPF syscall, so that we can see if other programs or malicious users or malware are manipulating our BPF programs or trying to run their own. We'll also be adding container support because in the Linux world, a lot of people are using containers to separate out their applications, and that brings a certain extra level of information required for system monitoring. So process identifiers, for example, are different inside a container than outside a container. And the other thing that we're definitely got on the horizon is to add support for BPF type format so that we can provide the same functionality on machines that actually have BTF support enabled. This will just give a more robust method of accessing kernel internals where that's available. With the rise of BTF Hub, we might be able to support other systems which don't have BTF and for one reason or another don't support our current mechanisms for accessing kernel internals. Wrapping those things together, Sysmon's got somewhere to go. And with it being out on GitHub, if you've got ideas, then obviously communicate with us via there.
Awesome. Thanks, Kevin. For procmon, built on top of eBPF, and we use an abstraction layer called BCC with the work that Kevin has done in Sysmon and today releasing the sysinternals eBPF library. We are starting work right away to removing our reliance on BCC and moving to the library that Kevin has developed to make it easier for us to get a wider distro and kernel support. For procdump, we are adding support as we speak. You remember how I showed you that you have to specify, a process ID and that targets a specific process? Well, we want to use the process group ID as well in those cases where your application will spawn a lot of child processes to do various things like handle requests or whatnot. So instead of having to tell procdump, go off and monitor each one of these individual processes, you can just specify sort of the process group ID and it will automatically handle monitoring all of the child processes. And the next thing that's on the horizon also for procdump is .NET counter integration. The way that procdump today gets all of this data is by grokking procfs, where all processes basically are exposed. Now, .NET has its own counters exposed internal to the runtime, and we want to be able to enable procdump to be able to work off of those counters as well. Those are a couple of things for procmon and procdump coming up. And for resources, here again are all the URLs for the GitHub repo. So sysinternals eBPF, sysmon proc dump. This is, of course, all open source, and we would love to get any and all good or bad feedback from you all. And we also, of course, welcome contributions. So if there's something that you're interested in seeing in one of these tools, feel free to jump on and can help out. Thanks, everyone, for attending this session. We hope you found it very useful. It's very exciting to see sysinternals tools coming to Linux. With that, everyone have a great day, and we'll catch you next time. Bye-bye.
Yeah, thanks very much.